Hello everybody. We're still in module 1, which is AC excitation to RLC circuit, and this is week number 3. We are going to discuss AC circuit analysis. Now our discussion will contain 2 points: circuit analysis using phasors and power in AC circuits. We will adopt the same let me say procedure, which is discussing the circuit operation, waveforms and formula. In circuit analysis using phasor, we are going to discuss phasors and impedances, Kirchhoff's law, nodes, voltage, technique. While in power in AC circuit, we will discuss power for general load, AC power calculation, and power triangle. Okay. Now, just as a common procedure, okay, when you deal with AC circuits, usually we are given time domain AC circuit parameters, as example, voltage, current. You need to convert from time domain into phasor domain. This is first of all, okay? So all voltages and currents should be in phasor domain, polar representation. Okay. Now for the impedances, regardless if it is inductive impedance, capacitive impedance, you need to, usually you are given inductance and capacitance, you convert them into their impedances. As example, ZL will be J omega L, while ZC 1 over J omega C. Convert them into Z, which is impedance. Then you analyze using this technique or that technique. Let's take different examples. Now look to this circuit. This circuit contains 3 elements, R, L, C, where you can see that the inductance is given in Henry, which is 0.3, capacitor in microfarad, which is 40, and the voltage given as cosine function, which is 100 cosine 500t plus 30. The first step is to convert this time domain circuit into phasor circuit. R, we keep it without change because it's already real, which is polar, okay? While impedance ZL is equal to J omega L with J2 pi FL. So we convert from Henry, as you can see here, into ohm, as you can see here. Now the capacitor 1 over J omega C, also we converted from capacitor into Z, which is minus. You see, capacitor in minus, the imaginary is in minus here, minus J50. Now you see, the voltage was 100 cosine 500t plus 30. We converted into 100 with angle 30. Very simple. First step is to convert it from time domain into phasor domain. You can see here 100 with angle 30. This is the voltage. ZL, J omega L, this is in ohm. And ZC 1 over J omega C, or minus J1 over omega C, which will be also in ohm. You have everything now. Now let me ask a question here. This circuit, the elements are series or what? Yeah, you will say this is series connection, correct? Then we add them. R plus ZL plus ZC. R is 100, J 550 minus J 50, real with real. There is no other real, it's only 100. But imaginary with imaginary give you J 100. Now we convert this Cartesian into polar. We know how to convert. I will not do it again here because you know it. It will be 141.4 with angle 54. Please use units. Don't forget, this is ohm. Okay? Now, by the way, I try to miss units in some places because I want to remind you and I want to add it in front of it. So please, you will be an engineer. You should not forget units. Okay? Now, this is Z. He asked me to find the current. Very easy. Ohm's law say that the voltage over Z. Voltage is given to me. Z I already calculated. Then this is polar division. So divide the magnitude, subtract the angles. You got this. This is the end of the story? No. You convert back into time domain. This is the maximum value. And this is the phase shift. So it's a procedure. You convert time domain into phasor domain. You do the AC analysis. Here we didn't need more than Ohm's law and connection, series connection. Let's see more examples. But before the other example, here I will try to show you the phasor diagram. Phasor diagram, we plot the current and voltages on the phasor, on the 4-quadrant figure. VS, you have it, and AS, you have it. Now, you see for VS, the angle is 30, which means here 30 angle from the horizon. This is VS. What about current? Minus 15, you go down 15 degree in the opposite direction. This is the current. Now let me ask you a question. What is the phase shift between voltage and current? You will say it's 45 because 30 plus 15 is 45. Correct. Now I want to plot voltage on resistance, across inductance, across capacitance. The current following through them is the same, so just need to multiply that by I. R by I here, we got this. Z by I, ZL by I, we got this. And for VC, ZC, which is minus J1 over omega C by I, we got this. I will just focus on the angle, on the angles. You see here the angle is minus 15, which is in phase, voltage of the resistance in phase with the current, which is what we discussed before. They are in phase. But have a look at the inductance. Inductance, the angle is 75 in positive direction. So from here to here is 75. Just a minute. I remember from previous week discussion, we mentioned that for inductance, the phase shift between current and voltage should be 90. Yes, correct. This is the 75 plus this is the 15, altogether 90. This is the current and this is the voltage. The same thing for the capacitor. Capacitor is minus 105. Okay, minus 105, it means going in this direction, right? Negative, which is mean clockwise. Okay, so from here to here is 90. One a little bit more, you got 105. But just a minute, we mentioned that the voltage and current, the relationship for capacitor is 90 degree. Yes, correct. This is the 90 degree, and this is the 15. You see? So it is 105. Now, just to remind you that you see for the inductance, the voltage here, the current here. So current is lagging the voltage. You see for capacitor, voltage here, but current in front. So current now leading the voltage. You need to remember this, please, for lag and lead. Lag for the inductance, lead for the capacitance. Another circuit here, we have series parallel connection. You see capacitor and resistance in parallel, while both of them are in series with the inductance. What is the first step? You will say convert from time domain to phase domain. Correct. 10 sine, just a minute. I need to convert to cosine, so I will say minus 90. Okay, correct. 10 with minus 90 here. Resistance is the same, which is 100, but inductance, it was here 0.1 Henry. I will multiply by omega, which is 1000. It will be 100, as you can see here. And the same thing for capacitor. Capacitor is 10 micro, 1 over omega C, which is 1 over 1000 by 10 micron, which give minus 10 J 100 ohm. Okay. Now what he asked me to find the voltage VC. Where is VC? VC across the capacitor here. Okay. So just a minute. Either I calculate the current and multiply by the impedance, or this impedance with this impedance in parallel. So I found their Z equivalent, which is ZRC. And since I have the current, I multiply current by Z. That's done. Because the voltage across capacitor is the same voltage across resistance. Let me take them one by one. As you see here, I converted 10 sine 1000t into phasor. 10 with minus 90. Minus 90 because sine converted into cosine will be minus 90. ZL was J omega L. I have omega, I have L. I got the impedance. The same thing for ZC, I got the impedance. Now the two impedances R and C and ZC equivalent is this 1 over R plus 1 over ZC. I do the math. I go through it. Please try to do it by calculator at home. You will find the final value in Cartesian is this. Okay, here. Now next is the voltage across the capacitor. according to voltage divider rule. Just a minute. Voltage divider rule in DC similar to AC in AC. Yes, the only difference is that we are dealing here in AC and phasor is the impedance. I would like to find the voltage across by the total voltage by the addition of the two series impedances. Now here we have complex. You take care of complex. As example, here you add real with real, imaginary with imaginary. You are here. This one to be converted into polar. We convert it into polar. Now magnitude to be divide, angles to be subtract, and then this is multiply. So magnitude will multiply, angles will be added. So this is what we got. Just a minute. Don't forget the voltage V. Okay, the unit V. This is the voltage across the capacitor. Now, if I want to write it in a time domain, then I will say the magnitude is 10 cosine 1000 t minus 180 volt. What about phasor? Phasor current. Have a look. The total voltage divided by the total impedances, equivalent impedance of the circuit, which is ZL plus ZRC. You go through the complex numbers here until you get the current in ampere. This is the total current. What about the resistance VC, which is the same voltage across C and R because they are parallel over R? It gives you this voltage, this current in ampere. And the same thing for IC, VC over ZC. It gives you this current in ampere. Have a look. The total current is the same current, the total current is the same current flowing through the inductance. This is the current through the resistance, and this is the current through the capacitance. Let me sketch them. Okay. Now, I across the resistance minus 180. So just a minute, this is 90, this is 90, another 90, 180, this is IR. IC is minus 90. IC is minus 90 from here to here, IC. And the total current here is with minus 135. So from here to here 90 and another 45. It will be 135. This is the current. This is how we sketch the phasor diagram. Now this is exercise to you. Please try to solve it at home. But I will take the example and see how we apply node voltage technique. Now in this circuit, okay, you know what I'm gonna do. I'm gonna convert it from time domain into phasor domain. So this voltage, you see sign, it will be minus 90. Okay, so 2 with minus 90. Resistance is 10, no change. And the voltage here in cosine, okay, this is 1.5 with 0 angle. And capacitor to be converted from microfarad into ohm impedance, and the same thing for inductance into impedance, as you can see here. Clear? Okay. Now what do you want me to find? The voltage V1. Just a minute. We have two nodes in this circuit. This is node number 1, equal it V1, and this is node number 2, equal it V2. May I ask a question here? We have two unknowns. How many equations we expect to write from this circuit for nodal voltage? You already discussed nodal voltage in level 1. You will say two equations with two variables. We solve them to find these variables V1 and V2. Correct. Now let me write the first equation. V1, okay, over resistance 10. This is the first word. V1 minus V2. Sorry, let me work here. Minus V2 over the impedance ZC, as you can see here, equal to the current injected into the node, which is 2 with angle minus 90. Now, node number 2, this one, V2 over this impedance plus V2 minus V1 over this impedance equal current injected into the node, which is 1.5 with 0. Now, we simplify this one and this one. You see two equations with two unknowns, V1 and V2. We solve them. You see, either by elimination, substitution, use a Cramer rule, whatever you would like, please go ahead. Here as example, I try to do elimination. You see, these are the set of equations. I will eliminate V2, so I will multiply here by 2, so this part will be 0.2, as you can see here. So I can cancel this part with this part. Now add this part with this part and this part with this part. We come up with this equation. Simplify, we are here. Do the math for complex. We got the voltage equal to 16.12 with angle 29.74 volt. Now we can write in time domain, this is the maximum, which is 16.12, and cosine 100t plus the phase shift, which is 29.7. More examples. Have a look at this example. He gave you here inductance and resistance in series with the supply, voltage supply. He asked to construct the phasor diagram showing all three voltage and current and what is the relationship between voltage and